Okay. Okay. All right. Inverse trig functions. Remember these? This is when we take a trig function and we reflect it. Also remember we put those restrictions, like when we're evaluating inverse trig functions, we have to put those restrictions to make sure it's 1-to-1 and onto. Remember that? Okay. No? We're looking.
What's onto?
Like, oh, onto is the horizontal line test. So for example, right, take sine, right? Oh, that's a really bad sign. Sorry about that. Yeah. I know, it was bad, right? So there's your sine curve. But if I want to talk about sine inverse, where am I going to restrict the values? From negative pi over 2, right? So I'm going to look at from here to here, from negative pi over 2 to positive pi over 2. Because what we need to make sure, first of all, in order for it to be a function, it's got to pass the vertical line test. And then in order for its inverse to be a function, it's got to pass the horizontal line test. So when we restrict those values, does this pass the horizontal and the vertical? Yeah. Yeah.
Can you remind one more time what all the inverses ranges are?
So, negative pi over 2 to positive pi over 2 for sine inverse. Tangent inverse is negative pi over 2 to positive pi over 2, but not including the endpoints because why? It has asymptotes there. It's undefined at negative pi over 2 and positive pi over 2. And then tangent goes, cosine inverse goes from 0 to pi. Right?
Thank you.
Sure. Okay. So I know it's really hard to see on here. This is just oh, did you get that all? Sorry. Here's just some function, right? Here's how do we find, so we have a point A, f of A. If we did the inverse, what happens with our x and our y values? They switch, right? When you're trying to find the inverse of something, we switch the places of x and y. And then if we want to find the derivative of that, what we end up doing is taking the reciprocal of the derivative of the original function at f of a, okay? It's a little confusing because we have to, right? So these are basically the derivative of the inverse is the reciprocal of the derivative of the original function. Okay, let's see how that actually, yes.
It's like 1 over the derivative.
Yeah, right here. I actually have it bigger here so you can actually see it. Okay, so if I'm asking for the derivative of the inverse, here's the situation. Sometimes it's not possible for us to find the inverse function. Okay, so let me give you an example. Let's say I gave you, let's say it's, I don't know, x cubed minus 2, for example. Can I find the inverse of that? Yeah, that's really easy to find the inverse. So, right, I would switch the values of x and y, and I could isolate, right, y, and that would be my inverse. Versus, let's say it's x to the 5th plus x cubed minus x squared plus 7. Okay. I know that's a function. That's a polynomial. It's to the 5th power. Okay, so I know that that's going to have an inverse function. Do I have an easy way that I could switch the x and the y's and isolate y? No, but I still want to be able to find the derivative of that inverse. Does that make sense? So this is why we use this formula, because I can evaluate the derivative of the original function. Okay, but to find the inverse, so if I gave you this and said, oh, find the derivative of the inverse and then evaluate that at, 2, that's easy enough to do. But when you get to something like this, I can't find the inverse algebraically.
So that gives you the inverse, the 1 over the original.
Okay, so yeah, here's how it's going to work.
Like what form?
So if I'm finding the derivative of the inverse at some value f of a, I'm going to find the derivative of the original function at a, and then take the reciprocal of that. Because remember with inverses, the x and the y, f of a and a, we switch the place value. Okay, I'll explain. It gets really, it's a little confusing in the beginning, but you'll get it. That's fine. I have faith. Here's an example. Here's my f of x. I have x to the 5th plus 2x minus 1. Again, can I find the inverse easily of that function? I mean, I can't. Maybe you can. You can, Ryan, but I can't. I can't. So here's a point. 1, 2. Okay. And I want to find the derivative of the inverse. So think of this as a f of a in terms of the formula. Okay, so notice what I'm asking for here. I'm finding the derivative of the inverse at 2, which is my f of a. Okay, so you see what it's asking for? Kind of.
I think if we do it, it'll just...
It will be fine. Basically, whenever you're finding the derivative of the inverse, this is going to be a y value on your original function.
Okay.
Do you want me to write that?
So A is y value.
So this is the y value on the original function. Okay, so just keep in mind when it's asking for a derivative of the inverse at a value, that's a y value on the original. Because remember, right, the function and its inverse, x and y are swapped. Right? Okay, so now what I want to do is I want to take 1 over the derivative of the original function at 1. Okay, so here, this is just a quick, right? If f of 1 equals 2, we know f prime of 2 equals 1. We know that, right? So let's find f prime of x.
Wait, wouldn't it be 0? F prime of 2.
No. Just when you have inverses,
Wait, no, that's f.
You're thinking f prime.
Yeah.
What's that, Ryan? We're just, yeah.
Oh.
Right, so if I said f of a equals b, this implies f inverse of b equals a.
Oh.
Okay? All right, so let's find the derivative of that function. So that's just easy. There's no chain rule or anything, just 5 x to the 4th plus 2.
I love the song.
Roland plays this song like every day.
If it gets too loud, we can close it. Okay. Now, why are we plugging in 1? Because I told you to?
Because it's like that's the derivative. X is 1.
Okay, the x value is the 1. That's what we want to evaluate it at. So, no. The 2 is the y value of the original, and we want to evaluate it at the x value. So that's just going to be 7.
7.
And then we just want to put 1 over 7.
Done.
Okay, so again, yeah, not quite. That was just the part, we didn't even get to the inverse trig function part yet. Oh, yeah, Ben.
I enjoy
I thought we were evaluating what you said like it says in the formula. Why did
We did. So
where did that go?
what was A? A is 1.
Yeah.
So you have to just get used to the notation. When I
I see. Never mind. I didn't notice.
it's basically saying I want to find the inverse of a y value of the original. So I'm going to take 1 over the derivative of the x value.
I didn't see on the front.
Okay, let's do another example. Okay. Typically you see these with like a chart. You'll see, I'm gonna have some on the practice test. That's how you see it, like in a multiple choice question on the exam. This is another way that you might see it. And it's all about picking the right values. Okay. So what do I want? I want F inverse, that derivative of 2.
What?
Okay. Is 2 an X or a Y value of the original?
Where's the original?
Y.
Y value of the original.
Oh, is the original 1, 2?
Oh, I thought they were like different ones and you just picked and
No, no, no.
between each of them.
Where's the original?
Is 1, 2.
Here, I have F of, so basically this is an example
Oh, this is-
where I give you more information than you actually need. Okay? I've got F of 1 equals 2. I've got F of 2 equals negative 1. And I have F prime of 1 equals 3 and F prime of 2 equals 4. Okay. What's F inverse of 2? 1. Remember I told you this is a Y value from the original function? Which one of these has a Y value of 2? It's the first one, right?
Wait, I'm so confused.
It's just like how
They're flip-flopped.
it's just the opposite. Of
It's just the opposite.
Oh, we're not doing the inverse. Okay. I mean
Okay.
the derivative.
I didn't do the derivative yet. I'm just getting you to, basically what I'm trying to get you to do is choose the point that I actually need to
First
utilize.
thing we would do is just find the inverse. Then next we try to find. Okay.
Right, so what does this mean? I want 1 over
Let's see.
F prime of 1.
Wait, this case, wait, never mind.
Okay, again, this is my Y value. So what I need to do is figure out, so basically this F of 2, I didn't even need. It was just there as extra, it was there to confuse
we have to
you.
do the first
Why?
part. So we have to find the inverse before we find the
Oh,
derivative.
we're just learning the lessons.
Okay, what's that?
We have to find the inverse before we find the derivative.
We have to find the values of the inverse before we do the derivative. So, because I have two different derivatives here. I need to make sure I pick the correct one. So basically, okay, again, do you want me to write that down? This is the Y value of F.
Oh, we did.
Okay, so this was negative 1. So if this had a negative 1 in it, then I would use this point. Okay, but since this was a 2, I'm looking for where there's a Y value of 2, which is here, which means I want to evaluate 1 over F prime of 1. It's a little confusing. It is.
Can you explain that one more time?
This is,
The first part makes sense. I was looking at the F of prime over 1, like on the bottom. Why exactly? Like I forget why.
Because you have to find the opposite, the reciprocal.
Of the.
okay,
You're always gonna put
Oh,
1 over.
yeah.
let me give you a different, let's use these same values. And let's say I wanted you to find the derivative of the inverse of negative 1. Okay.
Oh, it's 1, 4.
Where is F equal to negative 1? At 2. So I want to evaluate that at 1 over F prime of 2,
Oh, okay.
which is
1/4.
1/4.
That makes sense now.
Okay, so again, the first part is trying to figure out what X coordinate I'm choosing, right? Because this is a Y value of my original, so I figure out what's the X value. And then I do 1 over the F prime of that X value. Yeah, happy.
The inverse of f prime of 2, so why isn't it 1/4? Like for
Because
like
the Y value of 2 correlates to an X value of 1. So
I see.
okay, Ryan.
So like the F of 1 and the F of 2, those two things on the top, those are the inverses, and then right next to them are the derivatives.
Well, these are actual points on the original function,
Okay.
right? What's in parentheses is our X value. What it's equal to is the Y value. Okay. So I know if f of 1 equals 2, I know f prime of 2 equals 1. If f of 2 equals negative 1, I know, or f inverse of negative 1 equals 2. That's all. It's just telling you what the points are. And then the second part is telling us the derivatives. And what we have to basically do is we have to figure out which point are we using and then which derivative we're using. And there's always extra information that you have to figure out what you need and what you don't need. Makes sense? A little bit. I know. It's kind of hard to wrap your head around at first, but it's really straightforward. If you can just memorize it, if that makes it easier, make a flashcard, whatever helps you to remember that that's the y value, choose the x value, 1 over the derivative of that x value. Okay, derivatives of inverse trig functions are actually easier. You just need to know the formulas. There's only 2 that you need to know. There are cosine inverse and secant inverse and cosine. All you need to know is sine inverse, and yeah, the formulas are a little tricky.
It's pretty easy though in this case.
No, it actually is. If you just memorize the formulas, it's not hard at all. Okay, so sine inverse of u is 1 over the square root of 1 minus u squared. And then I have this times du dx. Now that we know the chain rule, this basically du dx part is if the chain rule applies.
Why is it a U?
It's just how they always represent it because they don't want to use
Is it the same
f
thing
or
as
g of x or... What's that?
Is it the same thing as like dy?
It's like dy dx, but
It's just like
we use u from here on out, basically. It will always be in this format. So when we
don't
do,
use v, we still use this.
do.
It's not like u and v.
Yeah.
we use u because we're going to do something later. So right now we're all working on derivatives, right? So it's like in elementary school, you work on multiplication, then you do division. So eventually we'll get to integrals, which is like our division part. And everything, we'll have something called u substitution. So there's a reason that we stick with the letter u for right now. Just get used to it. You'll see it in all the formulas. Okay. The derivative of tangent inverse, 1 over u squared. Du dx, again, that du dx just represents if the chain rule applies. Okay. All right, we got this. Yeah, Ben.
Does the absolute value of u less than 1, does that mean u?
It does. It just means they just put that restriction on. Well, why? Well, think about what values can we have.
Only goes to 1.
Well, think about the domain of the square root of 1 minus u squared.
Yeah.
Can u equal 2?
Yeah. Oh wait, no.
No, because then I'll get an imaginary number. So-
anyways, you'll know.
Yeah, you're not going to have you're not going to have something where it's whereas here there's no restriction for you. It's just saying like you can. We never work with imaginary numbers in calculus. It's all real numbers. Okay. All right. Here we go. Maybe what you want to do for this is think of sine inverse, and then this is 2x to the 1/2 power. Okay, we want to find dy dx. Again, there's going to be a lot of formulas for derivatives, whatever helps you to memorize them, flashcards, Quizlet, whatever.
Is the u here just
The u is this whole
thing?
thing.
Oh, okay.
Okay, so first we're going to have, so the formula is 1 over the square root of 1 minus u squared. Well, that's just going to be 2x then, right? Square root of 2x squared times, now comes our chain rule. Now don't worry about that, right? We're done with taking the sine inverse part of the derivative. We've done that.
So we don't include the sine.
Yeah, there's no sign in our answer. There's no sine inverse, okay? It's just going to be some expression in terms of x. Okay, so we're going to move the 1/2 to the front, 2x to the negative 1/2. Don't forget times 2, so that's a 2-step chain rule. Okay. Oh, well, the 1/2 and the 2 will cancel. And let's see. How can I rewrite this?
1 over.
Okay, 1 over. Now, technically, that's 1 over the square root of 2x. You can, I'm actually okay if you keep it separate. That's not, or if you want to combine it all underneath 1 square root, I'm fine with that. I'm not real picky. So you can just do like 2x times 1 minus 2x. You can distribute it if you want, not necessary.
So
Makes-
is the chain rule just always going to apply then, or no?
Well, it will unless I just ask for sine inverse of x. But normally I'm not just going to ask for sine inverse of x. There's going to be something. That's all. Okay. Let's try the tangent. Remind us what the tangent is. It's 1 over 1 plus u squared. And then du dx is our chain rule. So dy dx. 1 over 1 plus, what's our u this time? X over 4. Now here we are going to have to do a little simplifying. One thing I don't like is complex fractions, so we'll deal with that. And then times, the whole thing gets multiplied by 1/4. Looks like I should have given you a little bit more room, but we can do it. So 1 plus x squared over 16. And then we multiplied that by a 4th, so can I multiply the denominator by 4?
You just do that.
And then maybe multiply by 4 over 4?
Oh.
To get rid of the complex fraction? Okay, so what will that,
Just 4 over 1.
yeah, so I can do that all in one step, right?
Yeah.
Multiply by 4, multiply by 4. So I'll get 4 in the numerator, and then 16 plus x squared in the denominator. That's fine. Good. Sorry, I kind of combined 2 steps in one just to save some space there.
Is that just to eliminate that fraction?
Yeah, just so you don't have a complex fraction. You won't usually see complex fractions on the AP. They'll at least get rid of that. Okay.
Wait, I have a question. Where did you get the 4 like times 1 plus x squared over 16?
Oh, right here. Multiplying by a 4, the same as multiplying 4 in the denominator.
And why do we multiply by?
Well, if I distributed this would be 4 plus x squared over 4, and I want to get rid of the,
Oh, you want to get rid of the 6.
so that's why I multiply by 4 over 4. Okay, next one, let's see. Now we have a particle moving along the x-axis. We got the position function, tangent inverse of square root of t. What's the velocity of the particle when t equals 16?
You find the second derivative.
Is it the second derivative?
The first.
Acceleration would be the second, yeah. Okay, so again, we're going to have that 1 over 1 plus u squared. So 1 plus t. I know, t's and pluses get mixed up, but times, well, the square root of t squared would just be t.
Square root of t. Got it.
And now what do we want to multiply by?
1/2 t. And then over 1/2 times 2. Oh, wait, no. I thought there was a 2 there, my bad.
That's fine. Now, the thing about simplifying stuff when you're trying to evaluate, you can plug in the 16 whenever you want. Or we don't have to simplify so much if we're evaluating, but I probably would at least maybe make it 1 over, what do you say, 1 plus t, or actually 2 times 1 plus t times the square root of t. Just so it's easier to evaluate. So we want v of 16. And what's that give us?
Yeah.
Oh, I did that so fast.
1 over
No.
1. It can't be ending in an 8. Yeah, because
Wait, would it be 17 in the middle?
Yes,
2 times
17, sorry, yeah.
So two
I was gonna write 16 plus 1.
34 times 4. 34 times 4 would be 100.
147.
136.
36.
I
was getting there.
One more second.
Okay, and I didn't give any units, so I'll just leave it as 1 over 136. Okay. Last example. Okay, tangent line is what we want to find. We have y is equal to tangent inverse. Okay. Do we have to use the chain rule here?
No.
No. So it's just going to be 1 over 1 plus x squared. If we did forget and try to do the chain rule, it would just be times 1, right? So if you always want to think, oh, I'm just going to try to do the chain rule every time, it doesn't matter. It'll just be times 1. Okay, so we want to evaluate. Oh, I don't know why I wrote dy dt. That should be dy dx. We'll do dy dt eventually, but
Is that different?
no, it's just when we get to related rates. Yeah, it's something we'll get to eventually. Next chapter.
I should have looked at this.
Okay, so plug in -1. So we get 1/2.
Yeah.
Okay. Now, what do we need in order to write the equation of a line? We need a point and we need a slope. So I need to figure out what tangent inverse of -1. This is where those restrictions we wrote at the top of this section, this is where they are very important. Okay, I don't want to write 7 pi over 4. That would be wrong, because our answer needs to be between negative pi over 2 to pi over 2. So this is where those restrictions come into play. So just make sure if you didn't write them down, go back and review those. So tangent inverse, it has to be negative in quadrant 4, but it would have to be what? Negative pi over 4. Right, because we're on the unit circle. It can only be in quadrant 1 or quadrant 2. And it has to be between negative pi over 2 and positive pi over 2. So,
Quadrant 1 and quadrant 4?
what's that?
Is it quadrant 1 and quadrant 4?
Yeah, quadrant 1 and quadrant 4. But we don't want to use like 7 pi over 4, because 7 pi over 4 isn't in that domain. Okay, and now what's the equation?
Y plus pi fourths.
Pi over 4 equals
1/2.
pi fourths. Is an interesting way to put it, but it's correct.
No, I'm the only one saying the answer here, so.
Go ahead, Ryan. I'm so sorry. Go ahead. Continue.
Plus 1.
Good job.
Yeah.
Yeah, 1/1.
I like that.
Go through the steps. Pi 4 simplified and for number 3. I don't know why I'm so confused.
Oh, I just found I have 2 example 4s. And B?
Yeah, I don't know why I'm so confused. No, I know. I'm still confused.
No,